Yes, welcome to chemistry lesson. My name is Wow Chemist. We're taking you through chemistry today. You're welcome to Vision Plus. This is the first part of organic chemistry, the introductory part. Saying organic chemistry is just a branch of chemistry that deal with the study of carbon compounds. We're going to start the carbon compounds, and those carbon compounds are found in living things. But at the same time, we are going to exclude the oxide of carbon. When we talk about the oxide of carbon, so meaning the carbon dioxide, carbon monoxide, we are not going to talk about them in organic chemistry. Then also the carbonates of carbons. When we talk about carbonates, this is the chemical formula, carbonate. So we have the carbonate of carbons. We are not also going to talk about them. And also we are not going to talk about the carbides of carbon. One example of the carbide is calcium dicarbide. So we are not going to talk about the carbides, only the uh, compounds found in living things. So here we have the organic compounds. Organic compounds, we are saying they are simply those substances that are made up of carbon and hydrogens. And this one, they are called hydrocarbons. So hydrocarbon, you shall see the definition ahead. These are organic substances which contain hydrogen and carbons only. That's why we call them hydrocarbons. So the word hydro is from hydrogen, then carbon. So, and then also we are saying that the major natural source of organic compounds is that one of crude oil. So, crude oil it consists of a range of alkanes. So we are going to see alkanes ahead, but alkanes, these are organic compounds, mainly the hydrocarbons that contain a single bonds in between the two carbon atoms. So, and therefore, for this matter, we shall see the possible way of separating them because when you talk of crude, that means it is not verified, still in its crude form. So for us to separate, we are going to use what we call fractional distillation. And when we use fractional distillations, we are going to base mainly on the boiling points. Why? Because these organic compounds at the same time they have different boiling points. And because of that reason, therefore, what we are going to get is the fraction. Why are we saying it is a fraction? Because if we say this is the whole part of, this is the whole thing, we call it crude oil. So this thing, when we're going to subject it to the higher temperature, we shall see that the components will have different boiling points, and this one will come out first, the other one will come out first. So what we are going to get is the fraction, not the whole thing. And we have seen some of the fractions here and their uses. We are saying gas, mainly we are talking about the propane and the butane. We are going to get propane ahead, but propane also is under alkanes. We are going to talk about it ahead. We are saying these gases are used for cooking and lighting. You use them for cooking at home, at the same time light. Then we also have petrol. Petrol, we can use it in motor and aviation fuels. Yes, for some of you want to fly, what they are putting in that engine is the petrol. We have the paraffin, or sometimes we call it the kerosene. It is also used for lighting and heating uh, at home and even in industries. Then we have the diesel oils. This one is used for making diesels. So diesels, there are some vehicles that can use diesels, others can use petrol, depending on how they were designed. Then we have the lubricating oils. So the lubricating oils are saying this one is used for lubricating part of machines. Like there are some part of machines that need like be lubricated. In other words, we want to make sure that the machines function properly, the moving parts are well functioning simply because of this oil. Then at the same time, you have waxes and vitamins. So this one we are saying they are used to make the Vaseline, greases, and the candles. But at the same time, we can also use this one for road and runway surfacing. When we talk about this where they're getting what they call the tarmac. So the remains from the crude oils Some part of it is used in making the tarmac roads, that black thing you see. But also we say that uh, those compounds that make up living or non-living should be alive or dead. They largely contain what? Carbons. Even perhaps human beings also have carbons in our bodies. So carbons exhibit some characteristics, and we are saying it exhibit stable covalent bonds with itself and with other non-metals. So covalent bonds, those are the bonds that are formed between non-metals, but sometimes also they can be formed between carbon atom itself. And we are saying those possible elements that carbon combined with them are that one of nitrogen. We also have oxygen. We have hydrogens. I know all of us are aware from senior too that nitrogen is written in this form because it is diatomic. Nitrogen cannot stand alone. Oxygen also cannot. So two atoms come together to form, so we call them di molecules, gases. But at the same time, we have halogens. We don't want to call them halogens, we call them the group 7 elements. And those group 7 elements, we have the fluorine, we have chlorine, we have bromine, we have iodine. All these one also, they behave like diatomic molecules. So two of them come together, they combine, and we see them. That's why we are putting these two. Then at the same time, because of all these things, we have seen that carbon is behaving in this way. Why? Because carbon at the same time is having four valence. So from your inorganic chemistry, we are saying carbon is having atomic number 6, electronic configuration. It is simply 2 is to 4. So if I say 2 plus 4, I will get 6. So therefore, for carbons to gain its stability, it is either going to lose these 4 electrons, so it is going to gain more 4 electrons to make it 8, so that will have stable electronic configuration. But in most cases, this 4 is given out. So, and this becomes the valence electrons we are talking about, to form what we call the strong covalent bonds. So it behaves like this. That's why we are seeing this carbon, we have 1, 2, 3. So the valence electrons. But at the same time, this carbon is capable of forming what we call the single bonds, the double bonds, and the triple bonds between itself. So one thing we have to know in organic chemistry is that carbon, for it to be stable, it needs 4 bonds like this, 1, 2, 3, 4. So for it to be stable. But you are saying that these carbon atoms, many of them can combine in this manner. So we are going to have like the single bonds between each carbon atoms. But at the same time also, this carbon also can have what we call the double bonds. So we are going to talk about this thing in hydrocarbons. So we shall see the double bonds. So that means if this one is having the double bond, we are saying that this carbon, for it to be stable, we shall have 1, 2. So I will add another one here, 3, 4. So that means this carbon is very, very, very stable. Then this carbon atom also we shall have 1, 2, 3, 4. But for this one, for it to be stable, because we say carbon must what? Be bonded to other elements using 4 bonds. So here we shall have 1, 2, 3, 4. Likewise this. So the elements you can add here sometimes we shall have hydrogen, we shall have hydrogen, we shall have hydrogen, we shall have hydrogen. And now we call this one here hydrocarbons. We are still seeing the reason why carbon behaves in this manner. Also, carbon atoms combine with each other to form. Okay, let me explain something about the triple bonds. So when you look at the triple bonds also, we are saying this carbon can also combine in that manner. So for these carbon atoms to be stable, it needs like to bond to another atoms of another substance, to bond to another atom of another element. So we shall have something of this kind. So when you count, we shall have 1, 2, 3. So the bonds are being shared by this carbon atom and this carbon atom. So we shall have 1, 2, 3, 4. We shall have 1, 2, 3, 4. So this is the key point in organic chemistry. The moment you miss that concept, it will be very hard for you to understand. And because of that reason, we also have seen that carbon atoms can combine with each other to form a very long, it's supposed to be very long chains or rings. So the long chains we are talking about, it can be like from, from Kampala to Juba. So carbon can behave in this form. This is carbon atom, this is carbon atom, this is carbon atom. But sometimes, if it is not in a straight chain like this, very long, sometimes also it can form a ring. And this is what we call the benzene ring. We are going to talk about this one ahead. So it can form a ring like this. It can form a ring in this manner. So here we shall have. Here there is carbon atom, here there is carbon atom, there is carbon atom, there is carbon atom, there is carbon atom, there is carbon atoms. We are going to talk about this chemistry ahead of us. Keep following us. So we are saying this manner is what we call catenation. So carbon exhibit what we call catenation. That's why it is in position to behave like that. But at the same time, we have seen that these covalent bonds, they form what we call, is going to be like a bond between carbon and hydrogens. And that takes us back to what we talked about earlier, that we have hydrocarbons. Now, these hydrocarbons, if they ask you in exam, what are hydrocarbons? You can simply say these are organic compounds that contain hydrogen and carbon only. This word only is very important because when we say hydrocarbons, we shall only be in position to see that we have carbon and what? And hydrogen only. Those are the elements that make up what we call hydrocarbons. Now, the recap here is that organic chemistry is simply chemistry which deals with the study of organic compounds. But we are saying we are going to exclude some of the compounds like the oxides, carbon dioxide, carbon monoxide, the carbonates, yeah. Then at the same time also, we are going to exclude the carbides, but there's that there's that bond between carbon and hydrogen. So that bonding it forms what we call the hydrocarbons. Then at the same time, I said example of crude oils, they are here with their uses. And at the same time, if you want to separate them, you get it in crude form. So that means it's not tempered with. For us to temper with it, we have to subject it to a very high temperature. After doing that, what will happen is that these substances you are seeing here, they have different boiling points. So they are going to come out, uh, they, they are going to come out differently. If this is you subjected them to heat in this machine, you will see them, others will come out fast, others will, just like that. Why? Because the suppression depends on what? On boiling point. So those one with high boiling points, you will get them later. But those one with low boiling points, the boiling point can easily be reached, and at the same time, you get that product. So that is the whole things about the introductory part of chemistry. See you in the next topic.